Have you ever wondered how small you really are? I'm not talking about feeling small when you stand beneath a towering skyscraper or when you gaze up at a starry night sky. I mean cosmically small. So small that even the numbers lose meaning. So small that if the universe were a vast ocean, we wouldn't even be a molecule in a single drop of water. Today, I want to take you on a journey of scale. Step by step, we'll zoom out from Earth to the planets, to the stars, to galaxies, and finally to the edge of the known universe and perhaps beyond. And with each step outward, you will become smaller than you can even imagine. But along the way, something remarkable happens. The smaller we feel, the deeper our sense of wonder grows. And sometimes, when we look outward far enough, we find something profound about ourselves. Number 1. Earth, the starting point. Let's start here, our home, Earth. Earth is a rocky planet about 12,742 kilometers wide. When you look at mountains, oceans, or cross continents, it already feels enormous. It takes hours to fly across a country, days to cross oceans, and weeks to circle the planet by ship. But Earth is small, very small. Let's take our first step outward. Number 2. The solar system, a lesson in scale. Next, we compare Earth to its planetary neighbors. Look at Jupiter, the largest planet in our solar system. It is 11 times wider than Earth. Its iconic Great Red Spot, a storm that has raged for centuries, was once large enough to fit 2 Earths inside it, though it has gradually shrunk and can now hold about 1 Earth. And yet even Jupiter pales in comparison to the Sun. Our Sun is 1.39 million kilometers across, a ball of plasma so large that over 1 million Earths could fit inside it. It also contains 99.8% of the mass in our entire solar system. Without the Sun, the solar system would not exist. Light from the Sun takes 8 minutes to reach Earth, but to reach Neptune, the outermost planet, light takes over 4 hours to travel. This is the first glimpse of cosmic distance, the vastness of even our local space. But we've only begun. Number 3. The space between stars. Now let's leave the solar system. In 1977, NASA launched the Voyager 1 spacecraft. After traveling for over 45 years, it has crossed the heliopause, the boundary where the solar wind meets interstellar space, though it remains far from the outer edges of the solar system, which extend much farther. And yet, the next star, Proxima Centauri, is still 4.24 light-years away. That's about 40 trillion kilometers. At the speed of a commercial jet, it would take you roughly 5 million years to get there. This is the scale of interstellar space. Huge distances with unimaginable emptiness between stars. And remember, Proxima Centauri is just the closest star. There are billions more. Number 4. The Milky Way, our galactic home. Zooming out again, we now view our home galaxy, the Milky Way. The Milky Way is about 100,000 light-years across and contains at least 200 billion stars. If you could count 1 star per second, it would take you over 6,000 years to count them all. And that's just our galaxy. The distance between stars is vast. In fact, if our entire solar system were the size of a coin, the Milky Way would be the size of North America. And yet, we are not done. Number 5. Galaxies among trillions. Beyond the Milky Way lies a sea of galaxies. The observable universe contains hundreds of billions, perhaps up to 2 trillion galaxies. Each galaxy contains billions, sometimes trillions of stars, along with countless planets and cosmic mysteries. When the Hubble Space Telescope pointed at what looked like an empty patch of sky the size of a grain of sand held at arm's length, it revealed over 10,000 galaxies in that tiny speck alone. Now imagine multiplying that across the entire night sky. If you tried to name one galaxy per second, it would take you hundreds of thousands, if not millions of years to name them all.
Number 6.
The monsters of the universe. As we zoom deeper, let's explore some of the universe's most extreme objects. First, neutron stars. These are the collapsed cores of massive stars. They are only about 20 kilometers wide, yet contain more mass than the sun. A single teaspoon of neutron star material would weigh over 1 billion tons. Next, black holes. The supermassive black hole at the center of the Milky Way, Sagittarius A star, is about 4 million times the mass of the sun. But even that is dwarfed by TON 618, one of the largest known black holes, with a mass 66 billion times that of the sun. Its event horizon is so wide that light would take over a week to cross it. In comparison, Earth is not even a speck of dust. But it's not just about objects, it's also about emptiness. One of the largest known empty regions is the Boötes void, a region about 330 million light-years across with very few galaxies. Imagine a volume of space so vast that entire galaxy clusters seem missing from it. And beyond this, the universe continues to expand. The observable universe is about 93 billion light-years wide, yet the universe itself may be infinite, stretching far beyond what we can observe.
Number 7. The cosmic void. But it's not just about objects, it's also about emptiness. One of the largest known empty regions is the Boötes void, a region about 330 million light-years across with very few galaxies. Imagine a volume of space so vast that entire galaxy clusters seem missing from it. And beyond this, the universe continues to expand. The observable universe is about 93 billion light-years wide, yet the universe itself may be infinite, stretching far beyond what we can observe.
Number 8. Time, the other scale. Now let's consider time. Earth is about 4.5 billion years old. The universe is about 13.8 billion years old. And yet human civilization has existed for only a tiny fraction of that time. If the age of the universe were compressed into a single calendar year, all of human history would fit into the final few seconds before midnight on December 31st. We are not only small in space, we are brief in time. Number 9. Light's long journey. Think about this. The photons from distant galaxies you see tonight began their journey billions of years ago. Some of that light started traveling toward us before Earth even existed, and yet it only now arrives to be captured by telescopes or fall on your eyes. In this sense, looking into deep space is looking into the deep past.
Number 10.
Reflection. What are we? So what does all this mean? We often think of Earth as big, even central. But in reality, we are not even a whisper in the cosmic scale. Earth, compared to the universe, is smaller than a grain of sand. And yet, against incredible odds, we are here, made of stardust, forged in the hearts of dozens of stars, able to look outward and inward. We are the universe becoming aware of itself.
Number 11. The ongoing exploration.
Even today, missions like JWST and Euclid are pushing the boundaries of our cosmic knowledge. They're helping us map galaxies, detect the first stars, and study dark matter and dark energy, forces that shape the fate of the universe itself. Each new image, each new discovery reminds us there is always more to explore. A beautiful humility. If there's one thing the universe teaches us, it is humility. We are smaller than we can even imagine, not just physically, but in time, and in scale. But that is not cause for despair. It is cause for wonder. Because despite our insignificance, we think, we observe, we question. And perhaps that is our role, to be small but aware, to gaze into the void and marvel, to be a fragile species on a small planet but filled with endless curiosity. In that awareness, we become something rare indeed, a universe that knows it exists. If you enjoyed this journey through cosmic scale, be sure to like, subscribe, and keep exploring with us. The universe still holds countless mysteries, and together we'll continue the search.